Google Cloud SQL. The last product we're going to look at here in the storage category is Google Cloud SQL, fully managed MySQL databases in the cloud. Google is essentially our DBA. They take care of not only the infrastructure, but all of those database administration tasks done at the server level. So they handle patch management, updates, replication, and all those other DBA tasks that we no longer have to deal with. We're purely responsible for the logical side of the database, building the relational structures within. So let's jump in and take a look at what Cloud SQL is all about. Cloud SQL is very simply Google managed MySQL servers running up in the cloud with support for version 5.5 and 5.6. It's a pay-per-use model without any sort of lock-in. You only pay for what you use. Obviously, they're highly available, reliable, and secure, and we can connect to them from virtually anywhere. Inside of GCP from App Engine and Compute Engine, outside of GCP from our external tools. And because it supports standard MySQL connectors, we can hit it from all of the other clients that we know and love as well. And of course, we have a RESTful API to manage our Cloud SQL resources, instances up there in GCP. We also have Cloud SQL second generation. Now, this is currently in beta, and this is really cool. This is essentially first gen with a lot more of everything at a cheaper price. So we get more throughput, more capacity, and a lot more bells and whistles. Some notable Cloud SQL features. It's familiar. If you've worked with MySQL in the past, this is no different. It's just that Google hosts it. And because it supports the wire protocol as well as those standard connectors, you can hit it from all the tools you already use to manage your MySQL databases. Flexible charging, again, pay-per-use model here, so there's no upfront cost, nothing that you're locked into. You can spin them up and spin them down, and you're only going to pay for exactly what you use. We have managed backups. Cloud SQL will retain 7 backups for each instance, which is included in the price of the cost. It makes it very easy for us to do restores or even point-in-time restores if necessary. As I mentioned, we can connect from anywhere. That means our GAE apps, our GCE instances, and even external applications outside of Google's network. It also supports all the scenarios for automatic replication. This is a really neat feature because essentially we can set up master and slave servers, right? So we have a master instance and its data is replicated to these slaves, which are read replicas. And it supports all the different scenarios you can think of. We can have both the master and the slaves in Cloud SQL in GCP. We can have a master in GCP and our slaves off-site, or we can have our master off-site and our slaves up in GCP in Cloud SQL. We can also configure our Cloud SQL instances to stay close to our GCE instances and our App Engine instances so we can get extremely fast, low latency connections between our apps and their data. Plus, we get Google grade security. All of your data is encrypted in flight as well as at rest. So whether your data is bouncing around Google's internal network or sitting inside of files or backups, your data is secure. Now, because our database is living in the cloud, there are a couple of limitations related to the MySQL language itself that we will not be able to use. Now, those objects that we know and love and work with daily, those are still all there. Stored procedures, triggers, views, you can work with those all day long. Not supported, however, are UDFs, user-defined functions, as well as built-in MySQL replication, and then any statement or function related to files or plugins. Things like load data in file, select into specifying a file, install and install plugin, as well as load file, all unsupported. Now, to interact with Cloud SQL, we have a couple of ways. To work inside of your databases, again, you can use all of the clients that you know and love. Here's an example using the standard MySQL client. Notice that we're connecting on the instance IP. So when we spin up these MySQL instances up in Cloud SQL, we're going to get an IP address that we can use to connect to it from anywhere. And many of your GUI tools that you're used to working with work just fine as well. I use Workbench all the time for my local machines, hitting my Cloud SQL instances up there in GCP. To interact with our resources in Cloud SQL, we're going to use gCloud SQL. So here's an example, gCloud SQL instances create, give it a name, and that would spin up a Generation 1 instance with all the default settings. So here are the command groups, the things we can do here at this level after gCloud SQL, and here are the commands within, in this case, the instances command group. We can do things like clone, create, delete, import, and export data, patch, which changes settings, promote replicas, restart, restore backups, and even set the root password. Now, as far as integration goes, again, we can hit these Cloud SQL instances from virtually anywhere. We can hit them from our App Engine apps using standard drivers like connector.j for Java or MySQL DB for Python. And it's very simple to authorize our App Engine applications to hit our Cloud SQL instances. All we'll need to do is use the application ID, tie it to that instance, and we'll be able to hit it, and all traffic is encrypted then between our App Engine app and our Cloud SQL instance. We can also authorize our Compute Engine instances to hit our Cloud SQL instances through their external IP address, so the external IP address of our GCE instance. And then we can configure our Cloud SQL instances inside of a preferred zone. So we can put them in the same zone as our Compute Engine instances, so again, we can get those low latency connections between the two. And this is actually something we will do in our lab. We will spin up our guestbook application on a Compute Engine instance and configure our Cloud SQL instance to stay close to that Compute Engine instance, and we'll also, of course, authorize access through the external IP address. And yes, we can even hit our Cloud SQL instances from external services and external applications. We'll authorize specific IP addresses or range of IP addresses using CIDR notation. As I mentioned, we can use standard tools from our on-prem environments to hit our Cloud SQL instances running in the cloud, and we can even configure read replicas that are running off-site. So another great storage product, and one that can take a lot of pressure off your operations team as well as your DBAs. So if you're currently hosting your own MySQL instances, this is definitely something you should look into. Your operations team will no longer have to deal with an infrastructure, and your DBAs will be able to do other things because they won't be wrapped up in managing servers and patches and backups and all the things that go along with that everyday DBA work. So that wraps up a look at our storage category, which consisted of Cloud Data Store, Cloud Storage, and Cloud SQL. Here's a nice comparison. So Cloud Data Store, again, is perfect for application data, right? Web and mobile application data, where it can store terabytes plus. Unit size is about 1 megabyte per entity. That's actually the max per entity. It's a NoSQL storage system, and you're generally going to use it with App Engine, although you can certainly use it from outside. And anybody know what you would use when you need petabytes? Yeah, that would be Cloud Bigtable, right? Cloud Bigtable, perfect for when data store is not enough. When you start in the terabyte range and need to scale up to petabytes, that is your other NoSQL solution for extreme data storage. So Cloud Data Store, structured objects. Cloud Storage, unstructured objects. We have virtually unlimited storage up there, petabytes plus. We have a maximum of 5 terabytes in object. Again, it's object storage, perfect for unstructured data. And finally, Cloud SQL, which is our relational storage, MySQL in the cloud. First generation instances, up to 500 gigabytes. Second generation instances, up to 10 terabytes. Our unit size, standard MySQL limits. Again, this is a relational database, and it's fully managed MySQL running in the cloud. Now, if you want a visual on where you should store your data, this is a great diagram that came out of the Google Cloud Platform podcast. And we'll talk more about that when we get into our support and resources nugget. But they did a podcast on storage, and this diagram came out of it, and it's perfect. So where should you store your data? The first question you should ask yourself is it structured? If the answer is no, Google Cloud Storage is your answer. If the answer is yes, then is it SQL? If the answer is no and you need incredibly high performance, the answer is Google Bigtable. If not, Google Cloud Data Store. And if you are dealing with SQL, is it big data? BigQuery. If it's not, Google Cloud SQL. A great little chart to help you guide you through which product you should choose for your storage needs. In the CBT Nugget, we covered Google Cloud SQL. And we saw that Cloud SQL is really just relational MySQL databases fully managed by Google. They take care of the infrastructure. They take care of the MySQL software. We are simply responsible for the logical layer inside of the database. I hope this has been informative for you, and I'd like to thank you for viewing.